So to me, one of the most fascinating aspects of digital transformation is actually empowering digital technology to transform products themselves. Commercial customers around the world are actually becoming the digital partners of the future, and you actually saw some of that yesterday when Jeff joined Satya on stage to represent the partnership that GE and Microsoft have now. But this is happening in many, many scenarios. Many, many commercial businesses are taking the product that they once delivered to market and now delivering it as a service. The X as a service market is going to explode as we continue to leverage digital technology to really fuel how products actually continuously improve. If you think about the power of instantaneous feedback, this feedback loop coming from customers and actually improving product design, improving serviceability of products, and delivering a better experience, the opportunity for all of us is simply fantastic. So we've got a super exciting scenario to share with you next. Please join me in welcoming to the stage Richard Baxter from Mesh Systems, Paul Steffes from Steffes Corporation, and Olin Lagan from Shifted Energy. Hey, Richard, how are you?
Good. Nice
hey, Judson. Olin, how are you doing?
Hi.
Paul? Thanks for joining us, guys. So look, I'm really excited to share this story. We've got props, so that always makes me excited. I think maybe what I'll do is set up this scenario for you before we dive in. Because we actually have 3 business partners working together in a way to transform products that I have a hunch you might never have thought could be transformed. So Paul runs Steffes Corporation, and he's created the product that has then been sold to Olin at Shifted Energy on behalf of Hawaiian Electric, which I'm envious of your attire. And Richard from Mesh is the implementer of the solution that they're about to share with you. So Olin, why don't you set up the problem that you're trying to solve?
Sure. Hawaii is beautiful. So we passed a law that by 2045, 100% of our energy must come from clean resources. But it's going to take some transformation, because we do generate renewable resources now, but we don't use it all. And so the grids just aren't set up to take in all these mass renewable energy. So like, you ever driven by a wind farm and noticed that even on a windy day, maybe the turbines aren't spinning?
Yeah, I've been baffled by that, actually. So why don't you tell us what that's all about?
Well, there's several possibilities. But the turbines might shut down simply because there's too much electricity on the grid. Let me explain that a little bit. Let's say a grid is capable of handling 100 gigawatts. If the wind is blowing and there isn't demand for it, it cannot get on the grid. If they'd put it on the grid, it would truly destabilize the entire grid, so the turbine must shut down. We need the ability to store excess energy, and electric grids aren't set up for that.
All right, so I'll be Mickey the Dunce here, but couldn't you just connect a bunch of batteries to it to actually store the energy?
If you'd hooked up all the batteries ever made to the US grid, you charged them up and you ran them, you'd power the US grid for a total of 7 minutes.
So a little bit of a scalability problem then.
Correct, batteries don't scale.
Got it.
Yeah, we actually waste a lot of renewable resources this way. In Hawaii, for example, when the wind's blowing, we throw it away. We have to burn oil later when we need that electricity, raising rates for everybody. I'll give you a couple of stats from Hawaii. In Hawaii, every year we spend $6 billion with a B dollars per year to buy imported oil. That's about $4 grand for every individual in Hawaii.
Wow.
And the potential is incredible. On Maui, if we shifted just 1% of our load to wind, we would reduce our load by 40,000 barrels. That's about 38 million tons of CO2.
Wow. Huge benefit. So how are we going to fix this problem?
So Judson, for the past several years, Mesh Systems and Steffes have been working together to bring an innovative new product to life. And for the past year, we've been testing this product with Shifted Energy and Hawaiian Electric.
Cool.
So let me show it to you.
Awesome. So, Richard, it looks an awful lot like a water heater to me.
Okay. Judson, this is a GETS water heater. Now, GETS stands for Grid Interactive Electric Thermal Storage.
I see.
Okay. So yes, it's a water heater. Its job is to make hot water.
Okay.
But by connecting it to the Azure cloud, we're able to harness and aggregate its excess thermal storage capacity. And we're able to use that storage capacity to capture renewable energy that otherwise would be thrown away.
Awesome. So the water heater actually is acting as a battery.
So it absorbs energy like a battery, but it discharges that energy as hot water.
Cool.
For everyday household uses, washing your hands, doing your dishes. So electricity is 18% of a typical household's electricity spend. So this is really an incredible step forward. And incidentally, storage in this manner is about 1/10 of the cost of a traditional battery storage solution.
Wow. So you're offsetting the need to use more electricity by using hot water that's already been created from the renewable grid.
Exactly.
That's fantastic. Cool. So let's take a look at how all of this actually works behind the scenes.
Well, let me show you Kapolei Lofts. This is a facility, on the west side of Oahu. And it has hundreds of water heaters, and they're in every apartment, and we call them endpoints. So, with our solution, we can control the entire complex as a grid of thermal batteries. We use the cloud to manage and control it. And here I'm going to show you right here the dashboard where we look at all of these water heaters. So you can see right here that we have 290 water heaters running right now, and those water heaters are actually only charging at 30 kW, and so that's consuming renewable energy right now. But it's interesting that there is still going to be plenty of hot water.
So in this case then, Paul, if there's a maximum storage capacity of 2,500 kilowatts and you only have 1,500 kilowatts stored, can then I assume that the turbines in the wind farm are actually turning now to actually capture more energy?
Well, the turbines might be turning a little bit, but we're only putting in 30 kW. That's not enough to supply the entire complex. But what you said is exactly true. We do have plenty of energy stored. We have those 1,503 kWh stored, so those people are going to be just fine. You're capable of making 100 showers. You're capable of storing 1,000 showers at for 10 minutes each. So here, let me just scroll down a little bit, and you can see right here, these are the bars over the last 24 hours, and in this particular hour, we were storing 1,375 kWhs. We're capable of storing 2,500 kWhs, so there's about a 1,200 kWh spread. And that's the gap that Olin was talking about. The amount of energy that this water heater is capable of storing. This aggregate group of storage water heaters is capable of storing.
Awesome. So this is showing us that water heaters are heating up, accumulating thermal energy, really whenever renewable sources are available to act again as that thermal energy grid for future storage of energy.
Exactly. And it's all being maintained by Azure and Azure IoT under the hood. Azure gives us the ability to respond every 4 seconds, moment by moment, to meet the real-time needs of the grid and ensuring that individual consumers don't run out of hot water.
So what happens when you actually have a problem with one of these water heaters?
So let me show you that. So let's, here we showed you all the aggregate devices. I'm going to drill down and look at one specific water heater. So they're all individually labeled, and we can look at them, and let's look at this one right here. And now we have wonderful visibility to make sure that the consumer's water heater is working properly. We can even notify the consumer that his water heater isn't working even before he is out of hot water.
Wow. And
we know it's working, and everything is ready to go, and they got hot water, and we maintain that type of telemetry. Let me scroll down one more time. And you can see the final page, where you have this nice graphics, and so the office engineers can use it to communicate with the maintenance staff.
So Olin, Paul's truly transformed a water heater in this case.
You could say that.
But what is the real impact for you and the mission that you're on with Hawaiian Electric?
Justin, that's a really good question, because 40% of the world uses electric resistance water heaters like that. and they can all be converted to take in renewable energy. So this is going to absolutely transform grids worldwide so they can take in more renewables. When you think about it, it's fascinating for me to think that Azure and Azure IoT can transform an everyday object into something that's going to be critical infrastructure for utilities worldwide.
Pretty fantastic.
You know, what a time to be working in the industry.
Yeah, absolutely. How about it? Pretty cool, huh? So to recap, Paul, Steffes is taking a traditional commodity hot water heater and really truly transform the product to leverage the power of renewable energy to have a difference on our planet, which is really cool. So thank you guys for sharing it. Richard,
Judson, thanks a lot.
Thanks, Judson.
Thanks, Paul. Thank you so much. So hopefully those 4 examples have really encapsulated for you the pillars of digital transformation. And so when you hear us really give that as a rally cry for how we engage with businesses and business decision makers within our customers, they bring to life scenarios that inspire you to drive and do more with your customers.